Flack math! Give me some math and I'll give you some flack. Flack math!
This is lesson 46. Remember our homework. Well, I haven't given it to you yet. Our homework is just problem sets 46 and 48. So easing back into stuff. Normally we have at least 3 assignments, but this week we're just going to have these 2. All right, today we're going to talk about conjunctions. So, yeah. Conjunction, junction, what's your function? So what is the function of a conjunction? What is a conjunction in grammar? Did you guys watch the cartoons?
The conjunction, junction, that's your function, like that. Yeah, I watched that.
Yes. Conjunction, junction, what's your function? That's right. Good job, Hope. So a conjunction is like, I went to school and I learned a lot. So I went to school, period. I learned a lot, period. So I could take those 2 sentences and make them into one using a comma, right? You have ands and ors and other things like that. But in math, you just have ands and ors. So I can't say I went to school and I went to the mall at the same. Well, I guess you could if they were one after each other, but you can't do both at the same time, right? Unless your school was in a mall like it used to be. It used to be over in Arvada and used to be in a strip mall thing. Never mind. But I went to school or I went to a mall. Went to the mall, okay? So, or I went to school and I learned a lot. You can do both of those at the same time. Some of you do that. Some of you not so much. Just kidding. But so those are conjunctions, and that's what we're doing. So let's translate that to math. I could say that a number is greater than 5 and it's less than 10. Okay? So you've got some options there. You got 6, 7, 8, or 9, or you got like 5.1, 5.01, 5.00000001. So that number is greater than 5 and less than 10. Okay, so that's basically what we're doing today. It's real easy. So if I said numbers greater than 5, well, what numbers are greater than 5? Six, 7, 8, right? But also, don't forget 5.1, 5.0001, and those things. All those guys are in there. So when you graph it, you can't just say 6, 7, 8, 9, 10. You can't just put dots there for 6, 7, 8, 9, 10. It's also all the numbers in between 5 and 6. So what you have to do is you have to shade everything. So that's everything in between all those integers too. So we've talked about this, and remember the symbol that protects the 5 from being shaded, because you could just shade really close right up to there, but then however close you think you can get infinitely closer, which is a crazy concept. Okay, so we're going to put a circle around that. That's our symbol. I call it an everything but. So everything but 5 needs to be shaded on the right there. Okay, so what if it's numbers greater than 5 and less than 10? So numbers greater than 5 and less than 10. Well, you do have like the 5.00000001. You have the 6 and 7, and then you have like the 9.999999999, right? So on the number line, if it can't touch 5 and it can't touch 10, everything can be shaded in between. So that is what we call an inequality conjunction. Okay, technically you could have greater than or equal to or things like that. So that's when you would fill in the dot and things like that. But this is basically a conjunction. Now you could say x is greater than 5 and x is less than 10. Those two things. But we're going to do something different. This is a better way to say it. If x is greater than 5, that means 5 is less than x, right? If I'm older than Zan, that means Zan is younger than me. It's the same truth, right? I just said it using different symbols or different verbs or adjectives. Okay? So I could say 5 is less than x, right? Now the reason I'm doing this is not to confuse you, but now I can do it in one statement. See, 5 is less than x, or in other words, x is greater than 5, and it's less than 10. So this is true, this is okay, but this is unnecessary to write all that out. Thank you. Okay, so if this is confusing at all, you're just listing the values from least to greatest. So 5 is the least in this statement. X is in between the least and the greatest, so that goes in the middle. And then 10 is the greatest. Those are your fence posts. Okay. So when you do compound inequalities or conjunctions, you're going to have fence posts, and you're either going to shade in between the fence posts or shade on the outside of the fence posts. Now this is a conjunction, so it joins two things together, but it's so basically what you're doing is this. Okay, so the statement looks a lot like the graph. You'll see how the 5's in the same place that it is on the graph. The 10 is the same place it is on the graph. The x is what you're shading, that's in the middle. So the x is always in the middle. The inequality symbols are always less than or equal to. But you're never going to write it like this. I mean, technically this is correct, but technically it's correct, but we don't write it like that. We always go left to right, least to greatest when you can. Okay, so this is the better way to write this conjunction. Okay. All right, so let's do a couple more examples, and then that's basically this whole concept. Morning. All right. All right, so here is example 1. Actually, we just did example 1. Example 2. I want to graph this conjunction. Okay, so I could say this with two sentences. I could say x is greater than -2. X is less than or equal to 4. Okay, so you could graph those two things separately, and you would get two things that would overlap. And where they're overlapping is what you want. Okay, but this is the easiest way to do this. Draw a number line right under it or over it, doesn't matter. And you could just put -2 there, 4 there. See how it looks just like that? This one's an open circle, this one's a filled in circle. And then shade in between and you're done. That's not bad, right? Another way to say this statement is x is in between -2 and 4. So the shading represents x. X represents the shading. X and the shading are the same thing. So there is shading in between -2 and 4. So you're going to shade. So -2 is to the left of the shading. And then the shading is to the left of the 4, I guess is what you could say. There's a lot of different ways to confuse this. So I'm just trying to cover each way that I've seen students confuse this. Okay, so see how they're always pointing to the left. It's either less than or equal to, depending on what they give you. And so you can just graph it exactly how you see it. Shade in between -2 and 4. The biggest decision, the hardest decision is to whether to shade them in or not. That's the hardest thing you have to remember. Well, remember if it's strictly less than, then you don't shade it. It's an open circle. And if it's less than or equal to or greater than or equal to or anything, you shade it in. Okay, because you want to include 4 in that shading. Okay, that's example 2. Let's try example 3. All right, let's see if you can write an inequality or a compound inequality for this. Okay, see if you can write it, yeah?
I got -5 is smaller than x, which is smaller than 0.
Almost perfect. What'd you do wrong? Anyone else? No. You should always point to the left. The arrows are pointing in the right direction. Nathan?
-5 is less than and
Less than or equal to. That's the only thing you did wrong, okay? So you just need that little line underneath it, okay? It's less than or equal to x, which is less than 0, strictly less than 0, okay? Guys, does this seem doable? And I know it's in this nice little box right now, but then when you get into your homework, you have 30 problems that are completely different from each other. So that's when this kind of stuff seems easy now, but then when you throw it in the mix, and that's what I love about Saxon, is that it forces you to know these concepts in the cute little box and outside of the cute little box, okay? So do you guys think you can handle this in a problem of 30 problems? Okay, good. All right, and then you might get homework that just says an English statement, numbers greater than -1 and less than or equal to 5. So numbers greater than -1 and less than or equal to 5, then you can write an inequality and then you can graph it. Okay, so let's see, -1, 5. This is so easy because you don't have to worry about the little dashes and stuff. You don't have to figure out how many numbers you're going to put on the number line. You just put 2 numbers on the number line. I don't care how detailed it is. Fill that one in, leave that one open. Remember, less ink, less ink. More ink, more ink. Shade in between and you're done. Okay? This is called a conjunction, which joins 2 things together. So see how there's a conjunction here, which there's overlap. But there's also a thing called disjunction, which means they don't overlap. They have nothing in common, okay? So for example, instead of shading in between, you would shade outside the fence posts, okay? We're gonna talk about that later, but for now, we're just doing conjunctions, okay? Good? All right, let's start. We probably don't have to spend too much time on it. I mean, we could just do all of 47 and then we just have 1 lesson on Thursday. Or we do 2 lessons on Thursday. What do you guys want to do? We could do 2 lessons today and 1 lesson on Thursday. We could do half of today's lesson today and half on Thursday, which is kind of weird. I'd rather not do that, actually. So do you want to do 2 lessons today or 2 lessons on Thursday? Thursday? So we're done for today? Okay, sweet.
Black math, give me some math and I'll give you some